If you'll go ahead and label your paper solving and graphing inequalities. If you'll go ahead and divide your paper into 4 sections, you're used to seeing the very first sign or symbol that is a less than sign. So if you'll write the symbol, and then if you'll write less than or fewer than, so this symbol means less than or fewer than. And when you learn to graph, you're going to graph this symbol with an open circle. And the reason it's open is because the number is not going to be included, and it's going to make a little bit more sense when we actually start graphing. And your arrow is going to point in this direction. The next one, if you'll copy down this symbol, and it means is greater than, is more than, or exceeds. And when you graph this inequality, you're going to also have an open circle. The arrow is normally going to point to the right-hand side. The third column, the symbol means is less than or equal to, is no more than, or is at most. If you notice that the top symbol is the less than sign, and it's just like this one. And then the line underneath it means equal. Now, it doesn't have to be both. It just has to be one or the other. So you either have, the number either has to be less than or the number has to be equal to. Kind of like when I give homework. I could say, I'm going to give you less than or equal to 8 problems. So I'm either going to give you 8 problems, which would be equal to it, or I'm going to give you less than 8 problems. It's not both. So if you'll go ahead and copy down this column, this time when we graph this inequality, you're going to have a closed dot that's going to be colored in, and the arrow is going to point in this direction. The last column, if you notice, it's the greater than sign followed with the equal part of the equal sign on the bottom. All right, so this is greater than or equal to. So it's either one or the other. It does not have to be both. Is no less than or is at least. So when we go to graph this one, again, this one is going to be closed dot. And the reason we're closing the dot in is because it means that the number could equal that. And if you notice down here, if it has a line, then the dot is colored in. Also on this one, you have the line, so the dot is colored in. Notice on these two, you don't have lines underneath it, so you leave it an open circle. Okay, so the first thing I'm going to do is I'm going to rewrite the problem. X plus 5 is greater than 12. And if I remember back to when I first started solving equations, I circled the variable, brought down my wall, and instead of bringing down the equal sign, I'm going to bring down the greater than sign. And I'm going to do things exactly like I did with the equations. All right, I circled the variable over here because that meant this is the side I'm going to work on, and I need to do everything on the left-hand side to get rid of all the numbers near the x because I want to get x by itself. So this tells me to add 5, so I'm going to do the inverse operation, and I'm going to subtract 5 on both sides. That cancels out here, which leaves me with x. And then I have 12 minus 5, which is going to leave me with 7. What that means is x is greater than 7. So I'm going to go ahead and graph. So on my graph, I'm going to put the 7 in the middle, and then I'm going to put two numbers or a number on both sides. So I have 6 that comes before and 8 that comes after. And then I'm going to go ahead and graph. All right, and I'm going to graph on the 7, and notice that if I look at my greater than sign, all right, it does not include the number 7. X is greater than 7, so 7 cannot be one of my answers. So I'm going to leave an open circle, and if you need to go back to the previous slide to look at the symbols, you may. So I'm going to graph an open circle, and notice that my arrow is pointing in this direction, and so I'm going to point my arrow in this direction. And then I always double check. So if I pick a number, any number on this side of 7, I could pick 8, 9, 10, it's infinite amount of numbers. And I plugged them into the X here, and I said 8 plus 5 is greater than 12. I could actually add up 8 plus 5, which gives me 13. Is 13 greater than 12? Yes. So I know that that is a correct answer. What you do need to know is that when you see this arrow here and it's pointing this way, that means that there isn't one specific answer for this inequality. There's not one solution. This question has an infinite amount of solutions. So I could plug in 8 like I just did, 9, 10, 20, 1,000. Anything, any number that is larger than 7 is going to be a correct answer. Okay, the next example, again, I'm just going to rewrite it so I have a little bit more room. All right, and this one reads x plus 10 is greater than or equal to 5. So go back to the original, how we did equations. I'm going to circle my x, bring down my wall with my greater than or equal to sign. And then I know that I'm going to work on this side because this is the side with the x, and I want to get x all by itself. So I'm going to look, and it says here that I'm going to add 10. So I want to do the inverse operation and subtract 10 on both sides. This cancels out, which leaves me with 10. And then on this side, I have 5 minus 10, so I could do the keep, change, different signs, subtract. 10 minus 5 is going to give me 5, and take the sign of the larger number, which is going to be a negative. All right, when I go to graph, I'm going to graph negative 5 right here in the middle, negative 6 on this side, and negative 4 on this side. And be careful because I almost just messed it up. Remember that your smaller numbers go to the left-hand side, and remember that negative 6 is actually smaller than negative 5. All right, if I look here, I have that line underneath. And if you recall back to one of the previous slides, that line means I'm going to have a closed dot. So if you see that line, it means you're going to have a closed dot on negative 5. So I have my closed dot here. And then I have my arrow pointing in this direction. And so what that means is x is greater than or equal to negative 5. So any number on this side of negative 5 should give me the correct solution. So I can go ahead and plug the negative 4 in right here where the x is. And if I wrote negative 4 plus 10 is greater than or equal to 5. And then I know that negative 4 plus 10, different signs subtract, which is going to leave me with 6, is greater than or equal to 5. And if 6 is greater than or equal to 5, you know that that is correct. I also could have plugged the number 5 in here where the x is, and it would have done the same thing because my answer would have actually been 5. Is 5 greater than or equal to 5? Yes, it's the equal part. And remember, it doesn't have to be both. The one thing I do want to tell you is be careful following the arrow here. As long as your variable comes first, you can follow the arrow. Okay, I'm going to go ahead and rewrite this. 10 is less than or equal to x minus 6. All right, don't let this confuse you because your variable is on this side. You're going to do it the exact same way. So I'm going to circle my variable, which tells me that I'm going to be working on this side of the equation. I'm going to bring down my wall with my less than or equal to sign. And again, I know I'm working on the right-hand side because I want to get x by itself. So this tells me to subtract, so I know I'm going to add 6 on both sides, which cancels this out and leaves me with x. And then 10 plus 6 gives me 16. All right, don't let this confuse you. However, we do want to change this up because on the example before, I told you you needed the variable to come first. So we could just rewrite this and make it the exact same, mean the exact same thing. I can read this as 16 is less than or equal to x, or I could read it backwards. I could read it this way. And if I read it backwards, I would read it as x is greater than or equal to 16. So when I go to graph, I have 16 in the middle, 15, and then 17 on the right-hand side. I know that ask yourself, is it open or closed? And you notice that you have this line here, so think about that. It should be closed dot. So I'm going to color it in. And my arrow is pointing in this direction, so I'm going to point it this way. Now, can I check it? Yes, I always suggest you check it. I'm going to plug in any number on this side of the dot. Could I plug in 16? Yes, because it's colored in. So if I plug in, I'm going to go with 17 just because that's easiest. So I would say 10 is less than or equal to 17 minus 6. 17 minus 6 is 11. Bring down the rest of it. Is 10 less than or equal to 11? And the answer is yes. Okay, I'm going to rewrite this over here as x minus 1/5 is less than, and I'm going to go ahead and change this into an improper fraction. 10 times 2 is 20, plus 2 is 22 tenths. All right, you know the drill. You circle your variable, bring down my wall with my less than sign. And then this tells me to subtract, so I'm going to add, and I need the common denominator. So I'm going to change this, I'm going to multiply the bottom by 2 and the top by 2, which is going to give me 2 tenths because I need common denominators when I'm adding and subtracting fractions. So instead of subtracting 1/5, I'm going to add 2 tenths, which is the equivalent fraction of 1/5. And I'm going to add it on this side also. Now it cancels out here and leaves me with x. And then on the right hand side, 22 plus 2 is going to give me 24 tenths. All right, and I do know that 10 goes into 24 two times with 4 tenths left, which is the same thing as x is less than 2 and 2/5. And I'm sorry, that's kind of hard to see. All right, can I graph it? Yes. All right, so I know that I'm going to graph with the 2/5, 2 and 2/5. So I know that I have my 3 here, my 2 here, and I know 2/5 is in between. So I'm going to draw I need 4 lines in between the 2 and the 3. 1, 2, 3, 4. And then the 5th line is the actual 3. And so I'm going to put my dot on 2 and 1/5, 2/5. And my arrow is going to point to the left. All right, and if I plug in a number, remember it's any number to the left. So I could we could plug in 2 on the top, and I'm going to write it up here. So I could do 2 minus 1/5 is less than 2 and 2 tenths. And really, this is fairly easy to look at. 2 minus 1/5 is going to give me 1 and 4/5 is less than 2 and 2 tenths. And that's pretty easy to look at. So yes, you are correct. This is the last example for tonight's homework. The rest of this video is going to be for the next night because we're going to get into multiplying and dividing of inequalities. Okay, this is part 2 of solving inequalities. You're going to be multiplying and dividing by positive numbers. So I'm going to go ahead and rewrite this. 4x is less than negative 36. And I'm going to go ahead and circle my variable, bring down my wall. And remember, I'm trying to get rid of whatever number is with the variable. So that tells me 4 times x. So I'm going to divide both sides by 4. It cancels out and leaves me with x here. And then I know that a negative divided by a positive is a negative. And 36 divided by 4 is 9. And if you need a quick reminder, remember a positive times a positive is a positive. A negative times a negative is a positive. A positive times a negative is a negative. And a negative times a positive is a negative. And remember, that goes for division also. Same rules for multiplying and dividing. All right, so back over here to my inequality. So I'm going to go ahead and graph. So I'm going to graph with the negative 9, negative 10, and negative 8. And it's going to be open or closed. It's going to be open because if you notice that there is no line under here. So I'm going to put an open circle on 9. And because my variable comes first, I'm going to follow the arrow, and the arrow is pointing in this direction. So it's saying that x is less than negative 9. So I can pick any number less than negative 9 and plug it in. So let's just go ahead and pick negative 10, and I'm going to plug it back in right over here where the 4x is less than negative 36. So if I said 4 times negative 10 is less than negative 36. All right, 4 times negative 10, a positive times a negative is a negative. 4 times 10 is 40. Is 40 less than negative 36? Or is negative 40 less than negative 36? Yes, because it's further left on the number line. Okay, on this one, we are multiplying and dividing by positive numbers. So I'm going to go ahead and rewrite this as x is divided by 4 is less than negative 8. And I'm going to go ahead and circle my variable, bring down my wall. All right, I know that I'm going to start working on the left-hand side because I need to get rid of the number with the variable. So that tells me x divided by 4, so I'm going to multiply both sides by 4. That cancels out, which leaves me with x. A negative times a positive is a negative, and 4 times 8 is 32. So it's x is less than negative 32. When I go to graph, I'm going to graph on the negative 32. All right, is it going to be open or closed? It is an open circle because I don't have a line underneath the inequality sign. So it's going to be an open circle, and I'm going to follow the arrow, which is pointing in this direction to the left. And so if I plugged back in any number on this side of my variable, it would make it a true statement. So I'm going to plug in, I'll think of something a little bit easier than negative 33 because I'm going to get a decimal. So let's do negative 36. So if I plugged in negative 36 divided by 4 is less than negative 8. All right. A negative divided by a positive is a negative. And 4 goes into 36 9 times. All right, which is less than negative 8. So negative 9 is less than negative 8. So that makes it a true statement. And remember that this does not mean that negative 9 or negative 36 is the only solution. What that means is that any number that is less than negative 32 is a solution. Okay, the last two examples of part 2, multiplying and dividing by negative numbers. And this is a little different, so I need to make sure you pay attention. On this one, I'm going to go ahead and rewrite it. Negative 2p is less than negative 50. All right, do the same part as circling your variable, bringing down your wall. But this time I don't want you to bring down the inequality symbol. All right, because the reason you don't do that is because when you multiply or divide by a negative number, you need to flip the inequality. So if I divide this side by -2 and this side by -2, I'm going to flip the inequality. And this is going to cancel out, which leaves me with P. And a negative divided by a negative is a positive. 50 divided by 2 is 25. All right. And then I can go ahead and graph this. So I have 25, 26 on this side, and 24 over here. And it's going to be an open circle because I do not have a line. And it's going to point in this direction. All right. Now, let's look at this. If I plug in any number on the right-hand side of 25, we can pick 26, and I plug that 26 back in here, it's going to be -2 times 26 is less than -50. All right. Negative times a positive is a negative, and 2 times 26 is going to give me 52. And so is -52 less than -50? Yes, you are correct. Okay, the last example, -x divided by 5 is less than 3. Remember that this negative can go with the x or with the 5. It doesn't matter. It just means that that whole side is negative. All right, I'm going to go ahead and do the same thing I did at the very beginning of doing equations. So I'm going to circle my variable, bring down my wall. But remember, since I am going to be dividing, this side is negative, I do not want to bring down my inequality sign. All right. This side tells me I'm dividing by -5, so I want to multiply both sides by a -5. And anytime I multiply or divide by a negative number, I have to flip the inequality. All right, that cancels this side out, which leaves me with x, and the -5 is canceling out this negative here, so I don't want you to get confused. And then 3 times -5, a negative times a positive is a negative, and I get 15. All right. When I go back and, let's go ahead and graph it. -15, -14, -16. All right, it's going to be an open circle on the -15. And that is because there is no line. And remember, my arrow is pointing in this direction, so I'm going to point this way. And so any number on the right-hand side of -15 would work. I'm going to pick a simple one like -10. So if I put -10 back in, -10 divided by -5 should be less than 3. All right, a negative divided by a negative is a positive. 10 divided by 5 is going to give me 2. Is 2 less than 3? Yes, you are correct. So the key to this one is just making sure that if you are dividing or multiplying by a negative number, you have to flip the inequality. Please put a star by that. Don't forget, otherwise your answer will be wrong. Please bring any questions that you have to class tomorrow. Good luck.